Okay, in my slides, I already updated this dy dx for the angle. So just in case you forget how to find gradient on the curve, right? This is what you learn in your Cartesian chart graph chapter. Okay, so you find your dy dx for the slope in the curve. Okay, then there are also additional information. Oops. For calculating the angle, right? On how to find this one. Also add in one extra graph for you, extra information for you on this one. Huh? Okay. Before we move on, just to recall the standard SOP when you deal with collinear motion. Every time you see a curve, first draw the center. Second one, draw the axis, tangent and normal. The direction of T will be following the motion of the object. It will move from lower to upper, then this direction. Okay. Then the next one, you add in V and A if you can. V will usually this direction. Right. This is VT direction. A, it depends. You can expand that later. Okay, then number 4. Write the equation. Okay, what are the equation? A equal to AN UN plus AT UT. If you're lazy to write again, just write AN equal to V squared over rho. If you're lazy to write this one, just write AT equal to V dV dt, and then you substitute accordingly. If V got equation, you dV dt. Okay, or you V dot. There's an equation for rho. Just write the equation, something 3 over 2. This one is differential. There's a long equation here. Okay. Now, so basically, these are the steps that we expected every time you see a curve in a question. You follow these steps. Okay, how I mark usually. This graph will normally 2 to 3 points, 2 to 3 marks. It depends on the complexity. Okay. Then this one, 1 mark. These two will be 2 marks to 1 mark. Sometimes I come in a pair. All right. So 1 to 2 marks here. This one, another marks. Of course, if the question give you the radius already, then this one, you write this one also, no marks. Just for info lah. Just for info. So you look at the question. If the question don't have the radius, very high chances you need to calculate this one. Okay. So here, if you calculate at least 6 to 7 marks just for the general steps here. Okay. Then after you solve, you know that this is vector. After you solve all this, you need to draw where is the direction of your. You need to draw the direction for these two vectors. So AN will be here. You need to update your diagram. So AN over here, AT over here. There's a direction and magnitude. So it depends. Either you want to top one or middle one, which is the theta. Magnitude, let's say magnitude A. How you find? Square root plus square root, square, then square root. How to find angle? Angle, it depends lah. Usually we use tangent theta equal the opposite and the side lah. It depends on your triangular. Okay, it depends on triangular. For example, this one 90 degree over here. So you find where's the angle. Okay. So these are the general steps over here. Okay, including these two. These two set normally 1 to 2 marks here. So if you calculate 2, 1, 3, 4, 5, 6, about 6 to 8 marks just to write all these things on the answer out of 25 marks. One question, 25 marks. Here, minimum you score 8 marks already without substituting anything. Yeah, so very easy to score for this module unless you make some careless mistakes, because it's always snowball, always carry forward the numbers in the previous section. Okay. Any standard steps? No, stop me if I talk too fast, or if I go too fast, you cannot catch up. Let me know. Okay, let's look at example 11. Observe the standard procedure. It will be as the same as what I write on the whiteboard here. No matter what kind of question, you look at the question, you see curve one, is under curvilinear motion question. So you follow the steps. So you're given a car, will travel in the horizontal circular track. So circular track, curve question. That has a radius of 300. Radius is given. So this row equation doesn't apply. You're given the R already. So doesn't apply. You only need to substitute this one inside here, v squared over rho. Substitute value over here. Okay, if the car increases its speed at a constant rate, you are given the A, 1.5 meter per over second square. Now here, the A, you are given the magnitude, you don't know the direction. Starting from rest, you know your V, VO is 0. Determine the time it needs for, and it reached for an acceleration of 2 meters per second. So you start from rest, you need to find when the acceleration becomes 2. Okay. So what is the speed at this instant? So when it reached 2 meters per second square, means acceleration reached 2, then what is it? Okay. So first, how you solve? Again, go to the diagram, you copy the diagram. First, copy the diagram, identify where is the center. The center is at the middle. Second, draw the T and N. You should be able to draw where is the T and N. Where is T pointing? T is here. Where is the N pointing inside the circle? Okay. Huh? Yeah, of course. You understand what is free, right? So again, you don't need to copy the exact half shape. Don't need. What I want to see is the circle, dot, and maybe this one you can represent with one circle or one rectangular. I just want to see object there. Or particle. You are looking at particle. Particle is one sphere or one object. Everything sum into one dot. But make sure your dot is bigger because this is a big car. Okay, once you have the A and N, N and T, the next step is what? V. You know where's V, right? VT, this direction. After you find VT, the next step is to find already. Write these two equations. This one don't need because R is given. If you don't see R, then write this one. Then the rest substitution. You have the V already. You need to find the V. In this case, V is given, not given. You need to find. Okay. So you have I just label C, AT, AN. Then this is the resultant of A. Okay, you use coordinate system, origin, so and so. Positive N directed in the center. Acceleration in tangent direction is 1.5 meter per second square. I think typo error here. Acceleration unit, meter over second square, not, this is velocity. Okay. Now, you know an equal to v squared over rho. Substitute. You can use the equation u equal to uv plus at squared because acceleration constant in this case. Okay. So substitute starting from rest, the velocity you don't know, but you know the velocity in tangent direction is 1.5. It tell you already constant rate. So again, 3 Newton equation, only rules is the acceleration must be constant. Then you can use the 3 Newton equation. So from here, you get one equation. V equal to 1.5 t is a linear equation. It's a linear equation. Okay. Now, once you have this one, you know your V, right? So you go back to the equation, this one. Okay. So you from this equation alone, you can solve for an and at. If you write in this sequence, you solve for V already, you know already. Something missing here. You have the V equation, you dv dt, you get 1.5. At is 1.5. This one, V squared over rho. Rho here is 300. V is in that one. V is 1.5 t and square. Okay. So this one is a quadratic equation. Your an is in the quadratic equation. So you have an and at. An and at. So at 1.5, an 1.5 t bracket square. Remember, this is bracket 1.5 square. So remember to square the 1.5. I've seen cases where students forget, you just bring the constant in front, then they square the things. Then it will snowball the rest of the answer wrong already. Okay. Now, from here, you actually can find the time already. Why? A is given. The resultant is given. Okay. Like this, the step like this. So for future slide, sometimes I don't show you this one. I assume you already know how to do substitution. This one, I'm very kind to show you. Okay. And in fact, I've spent a lot of time doing the slides. Okay. So you substitute, there's only one unknown. Rearrange here and there, reshuffle, rearrange. There's only one t there. And remember, this is a square root and square. You will get two answers. Means you arrive at a quadratic equation. Quadratic equation solved by using the x equal to minus b. That one. Yeah. Y equal to ax squared plus bx plus c. To find the root is what? Minus b plus minus square root b squared minus 4ac divided by 2a. You should already know this one. Okay. Or even though in calculator, there is a function to find root. You only need to key in this one. Press solve, it will tell you the x. In exam, you don't write this one, also I don't care. As long as you give me the final answer correct. Okay, but you have to write something lah, solving for the root or solving for the x. You have to tell me lah what you are doing. Then don't suddenly give me one number. Okay. So solving for positive value, this is your homework. Because time don't have negative one. Time always positive, either 0 or positive value. So the answer will be 1.3.28, minimum 2 decimal place. Minimum 2 decimal place. Or 3 significant figure. It depends on cases. Have you seen this one? Yes, no. Yes, okay. So what is speed at this instant? The question asks you, what is its speed? Speed is the scalar magnitude of v. What is your v equation? What is your v equation? You remember? Yeah. So you just substitute lah. V equal to 1.5 t in the previous slides. You arrive at one equation by using the Newton equation. You remember just now the Newton equation? Substitute this value here, you get v. You get the speed. We ask you for the magnitude and not direction, and not the vector. If the questions mention about velocity, then it's vector. Vector, you need to tell the direction and the magnitude. Just be careful lah on the speed and velocity. Okay, answer will be 1.9 meter per second. Don't write 20.0. Because if you press calculator, it will be something 1.89 something. 3 significant figure or 3 decimal place, depends. Okay. Okay. Number 12 is industrial problem. Nowadays, you cannot run away from the conveyor system. I think even after you graduate, you go working, you will come across a robotic system or conveyor system. Okay, so you go to the question. The box travel along the industrial conveyor. If the box starts from rest, it tell you the V already. Oh, sorry, I need to give you all information. A is here. Okay, A is here. And again, this question is inside the tutorial question in Canvas. So it can come to, before you come to class, go download the tutorial. You can print it out, or if you're lazy, just download into your handphone or tablets that easy to read. You don't need to copy the question every time. Okay, so start from rest, A, and increase its speed such as acceleration now, AT equal to 0.2 t. This is what? This is acceleration, not constant. You cannot use the 3 Newton equation. This case, you cannot use Newton equation because acceleration keep changing in the term t. Determine the magnitude of its acceleration when it arrives at B. B is where? B is here. Okay. Okay. So this question application will be when you design a conveyor system, you need to know what is the speed when it arrives here, so that you can control the speed of this conveyor. If not, then it will either too slow or too fast. If you design, you do setting of this conveyor system, if it rotate too slow, then they will jam already. Either queue up jam, or your operator at another side cannot cope with the speed. Okay, so you have information of A, you have information of B, you have information of this radius 2 meter, and there's a speed here. Okay, so what do you do? Again, start with the center of the curve. You see curve, right? Go and find the curve, mark the center. Second steps, draw the normal and tangent direction of the curve. It depends of the question. Your interest will be here, not here. So your interest, this one also end of the curve. This one also end of the curve. So this one is T direction, this one N direction. You still remember there's one slide, what happened if the particle go into a straight line? What happened to the acceleration? Acceleration belongs to AT or AN? AT, If the particle follow one straight line, it is AT direction. Okay. So A to here is 3 meters. This one is in straight line. box start from rest at A, increase as speed such as AT equal to this one. Okay. All right. So how do you start? How you start? You start labeling where all the coordinate system, center of the curve, where is the N and T. This is the curve, but your interest is B, so no matter what, it's still tangent direction because box is going this direction. Then normal this direction. Okay. Then if can, you draw where is the V. If can, the next step is to tell yourself where is the velocity tangent direction and acceleration maybe cannot. But VT always you can tell. VT always tangent to the curve. So when it reach here, V is in this direction. Okay. Now V, this box go this direction. Here then, when it reach curve, always tangent to the curve. The velocity always tangent to the curve. Okay. After this one, go and write this equation. Write the acceleration equation. Write A equal to AN plus AT UT. You can rewrite this equation again, or you can write like what I write on the whiteboard here. Write AN equal to V squared over rho, AT equal to V dot or dV dt. Then, if this case already given R, so you don't need to write this one, but have a hot habit of writing this formula because you don't know whether this one come out or not. It's good you spare this answer. Okay, acceleration. Okay, acceleration. The box start at A. AT is 0.2 T. So what is the acceleration? Right. AT also means what? A also means what? Recall the first chapter, first session kind of lecture. A equal to dV dt. So AT equal to dV dt, and then you have an equation here. You want to find velocity. So how to do? Pull your dt to the left-hand side. Then you have dt one side, dv one side. Then you don't like d something, put in the curly integration sign. Then you integrate. Once you integrate, you get the v equation already. Once you get the v equation, you can find the velocity from here to here. You have the distance. Okay. The rest is just mathematics steps. You integrate. Only careless mistake is here. I'm seeing for the previous semester is the limit here. You might put the wrong number. This side is dv. So put in the velocity. I put in 1 purposely here because some of you might put 0 here. You might assume this one is 0. Because nothing here. So mentally, you might put 0 here. I just put 1, just precaution. From 0, the question already tell you from rest. Until what velocity you don't know. When the thing that you don't know for the engine dynamics, put alphabet. Don't assume. Don't assume. If you think they don't know, put alphabet there. This one is velocity. Then for the right hand side, the T1, also same. Start from rest, 0. Unless the question tell you it start from 10 seconds or what. This question doesn't mention anything, so 0. Until a certain time, you also don't know, so put T there. The rest is just integration steps. So I just move forward. You will arrive at 1.1 T squared. Okay, you have the V equation already. So for the time it needed for the box to reach B, so we only need to find this equation. Because this equation, 1.1 T squared, it means from A, it will apply this equation from this point until here. So again, recall the first two lecture. What is V definition? V equal to ds dt. V equal to ds dt from the previous one, you know your V is 1.1 t squared. You want, and what information you have? You have the displacement, you have the distance, right? So pull your dt to the right hand side. Again, you see d something equal to d something. Go and add the curly integration sign. Then integrate, you get one equation. Then go back to the diagram, substitute any value that you see in the diagram. Okay, the next set is all mathematics, so I'll skip. Okay, you should present something like this. Right? Again, things that you don't know, put as alphabet. For example, the S you don't know, so you put S, and I label it B because I focus reaching B. Without B also correct lah. This is just for precaution. Time also I put a B because I focus on reaching B. Okay, at the end you reach one S equation. S equal to 0.1 divided by 3t cubed. You can calculate the S, right? From A to B. 3 plus, here is circumference. What is the equation for circumference? Huh? 2 pi r. Circumference equal to 2 pi r. And then you know that one circle, 360 degree, equal to 2 pi r. No, cannot say like this. All right. So this one is quarter. You want to find here to here. 2 pi r is the full circle. But here, you know that this one is quarter section of circle. 90 degree here. 1/4, 2 pi r. Then substitute the r inside there. You find the circumference plus the 3 meter. You get answer for the left-hand side, SB. Okay, then only left out the T answer. Left out the T answer. And this is cube root. This is cube root. Okay, the rest is there. S is there. Substitute, find T equal to 5.690 seconds. So once you have the time, you can find your acceleration already. Once you have the time, substitute back your AT equation. 0.2 t pull here. You know your AT. AT is exactly the acceleration in this tangent direction. Oh. Okay. V also you can find, because in terms of t, substitute the time value here, and you solve for the answer. So V equal to 3 point something, again 3 significant place or 3 decimal place. Okay. Okay, once you find your AT, you can solve for this equation already. You know your V, AN, you have AT, but you need to solve for AN. AN, again, go back to your notes there. AN equal to V squared over rho. Substitute V divided by rho. Rho is the radius here, because this is a curve. AN and AT is for the curve. Don't use it for straight line. So once you do it, you'll find AN. Substitute, find the magnitude. Magnitude is square AT plus square AN square root. Your A will be 3.36, 5.36 meter over second. Don't forget about the unit. So this is how you solve the question. Basically, we keep repeating and repeating what I write on the whiteboard here. Okay. Only additional to this example 12 is you recall the definition of V equal to ds dt, A equal to dv dt. This is the tricky part lah in this question. Cannot say tricky part lah, but they assume you already know the relationship. Okay. Careless mistake maybe in the integration process. You might put in the wrong limit, or you're too fast substituting the number in, then some parameter missing. Any question? Everyone good? Okay. Anything that you need me to explain? No. Important you understand the concept. You understand the concept. Okay. We have done with the normal N and T. Now we go into cylindrical component, where you can no longer use N and T. You need to use polar coordinate. Polar coordinate means what? Okay, let's say you have a particles moving in the curve, and from one of the reference point there, let's say R is a position in curve motion. O to R, you get a object there. Okay. So here you need a reference line in the horizontal position is in the theta. For this subject, theta usually we measure from anti-clockwise. We follow your right hand rules, where your finger always curve this way. Okay, so always curve this way, and refer to horizontal. Have this habit, every time you measure angle, always have a practice of anti-clockwise direction. You measure from the horizontal, follow your right hand rules. Okay. Okay, I put this one in the slides just to tell you. This is called, the angle here is called transverse coordinate. Okay, transverse coordinate, theta. So sometimes the question asks you to find this theta. Okay. This one you learned in statics already. It's called unit vector. Unit vector, what I mean by unit vector? You take the position vector divided by magnitude of vector. Unit vector equal to R vector divided by magnitude of R. Unit vector always have one magnitude of 1. Okay, so this one. If you don't know, come to my static class. Okay. Okay. So in polar coordinate, we no longer use N and T. We'll use angle, theta and R. You see the two direction. One is the R, or you can see it as radius, but in this case, we see it as a position from the origin. This direction, positive R. And this object moving up, angle positive this direction. So going this direction, theta. And the angle between axis R and theta will be 90 degree, always like the N and T. It's just that this question set in the polar coordinate domain. Okay. So don't confuse with the R and theta polar coordinate question and the normal curve question. Don't mix up the N and T axis and the R and theta axis. R and theta, R is from the origin, straight, you use your ruler, draw a straight line. That is your R. The direction of this theta, it depends on the rotation, or it depends on the motion, either move up or move down. If this particle move up, then pointing this direction. If this particle move down, then theta positive this direction. Then we put in the unit vector, which is the direction of that axis. In this case, you have r and theta, ur and u theta. Okay. So next one, the rest you read. So ur direction increasing r when theta fixed, means theta you fix, you do not move. This axis is positive in this direction. Unit vector increasing r. So in this direction, this theta is increasing when r fixed. It means what? The r fixed in this direction, and you move this vector. So the theta changing. Okay, increasing theta, this one is in the anti-clockwise direction. This is called increasing. Okay, moving backwards is decreasing. Okay. So you are seeing this vector. Vector r equal to magnitude and direction. Vector r equal to magnitude of the r and the direction of the r. You're seeing vector form here. R equal to magnitude and direction. So to find the velocity, you actually, this one is your position, like what you did, ds, v equal to ds dt. Just change the s, become r. Okay, v equal to r dot, which is the time differential of this one. Dr dt, again, this is two vector. You apply the chain rules. You apply the chain rules. So fix this one, du, dr, du over dt. Fix this one, dr dt. Okay, use dot products. You arrive at this one. You get r dot ur plus r dot ur. Okay, dr dt is r dot. du over dt is u dot. Okay, one interesting thing is this one. You look at this one. Du over dt. What does it mean? Does it change over time? The answer is no, because this direction always remaining in this direction anytime. So du r over dt equals 0. Okay. So the rest you read. Okay, the rest you read. Only I want to show you the final equation that you will be using, like acceleration. The rest you read. The rest you read. Derivation, you can read during your free time. If you don't understand, can come to my office. It's a lengthy equation. At the end, you arrive at this equation. Okay. So V equal to VR UR plus V theta U theta. Also same, two direction. One is R direction, one is theta direction. Also vector. Remember, vector have magnitude and direction, same like the acceleration just now. We are deriving in polar coordinate. So this is what you need to do, and copy the first one here. Copy the top here. UR equal to this one. UR, you write lah. UR equal to U dot. Oh, sorry, not U dot. Equal to UR equal to R dot. R dot means V equal to ds dt. Now our S you replace as R, so it's dr dt. Okay. Then V theta equal You have two things there. Huh? You have r and theta dot. You have r and theta dot. So you need to calculate what is theta dot. D theta dt. Huh? This one is d theta dt. So as long as you write this one and this one, it come by one pair. So when you see the question give you circular motion, but in polar coordinate, you write this one anywhere in your answer. Then you do the same as what I did just now for the acceleration. You substitute the missing parameter. Then you draw in your free body diagram. Free body diagram, this one you have r coordinate, r vector and theta vector in v direction. So v in r direction, v in theta direction. These are two vectors you can combine with the parallelogram law. So combine these two vectors, you get resultant. How to find resultant? You find the magnitude, square this one, plus square this one, square root. This is a right angled triangular. You draw a rectangular triangular here. You can use theta to find the theta over here for the resultant. This is a triangular, so this is a right angled 90 degree. There's a triangular you can find. Huh? So this is just an illustration for you. What important here, you know how to find the V in the R direction and theta direction. Magnitude still the same because it's the vector. Vector you square plus square, square root. Direction, oops. Direction of V, actually you don't need to find. Direction of V always tangent to the curve. Okay, means the resultant. Means the resultant always tangent to the curve. Yeah. Or tangent to the path on the curve. So your answer you can put in the theta by measuring from r axis or theta axis. It depends on question, depends on your preference sometimes. As long as you give where is the theta. Theta equal to tangent, tangent theta equal to y divided by x. Right? Acceleration still same. I will just keep all these things. So you start from v, you acceleration dv dt. There's a lengthy derivation which you can read at your free times. At the end, again, in the test, we won't ask you to. In the exam, we will ask you to derive the equation. We'll ask you to apply the equation. Okay, there's a lengthy equation. This one you can skip. At the end, you arrive at one equation. A lengthy equation, lengthy derivation, limit here and there. You arrive at this equation. Copy this equation and put anywhere in your answer. With the second equation for polar will be acceleration equation. A equal to an, not an, ar ur plus a theta u theta. And what is your an? Ar, right lah. R double dot means different time differential 2 times of your r. R dot means the time differential, get the answer square. The answer. Then here, for the a theta, you got 2 components you need to calculate. You need to find the theta double dot means time differential, the theta. So the theta will be in the equation. You need to differentiate 2 times. Then this one, r theta 1 time and theta 1 time. So what does it mean in polar coordinate question? Okay. Polar coordinate question, you need to write A equal polar coordinate. Means you deal with r and theta. So you need to write A r u r plus A theta u theta. And there's an equation for these two. V equal to same V r u r plus V theta u r u theta. Also have the equation for these two. The background operation you need to do is r double dot theta double dot, then substitute inside the equation. Yeah, you need to do differentiation for r, 1 time, 2 time, for theta, 1 time, 2 time. You get the answer already, substitute back here. Because all this dot here, this answer. Again, we won't ask you how you arrive at this equation. We only care whether you know how to apply or not. Okay, so a lot of information I know, but at least you understand what is important, what is not important. Okay. Then you draw the diagram. You need to tell at the end, tell me where is AR, where is AN, then complete the parallelogram, find the resultant. Always say, you after you find the vector already in N or T or R or theta, find the resultant. Square plus square, square root, angle, use the tangent theta equation. Then you solve the question already. Okay, at the end you tell, what is the resultant, where is the direction. Okay, so nothing complex. Okay, this one you don't need to memorize because you only need to memorize one set, then the rest is come automatic on. Okay. One highlight here, A will not be taken to the curve. Only V, only V, only V. Only V. Just now is 2D, 3D, just add one more axis. I won't ask you 3D. This is for your info only. Okay? Z is further, you need to memorize one more. This will be this one. If this one come out, I will let you know. For this moment, I don't set 3D question for polar and for cylindrical coordinate. Okay? Just for your info, there's a way of finding it if it's 3D. Okay. Okay, I go very fast for example 13, then we have 10 minutes breaks. We go this one first. Okay, observe how we solve. It's actually a standard steps one. Okay, so you are seeing this one, amusement park. You see a rotating along the circular path. You know this is circular question already. Only two choices. Either ask you in tangent normal direction or ask you in r and theta. The steps are almost same. Okay. So you are given r radius, arm OB, arm OB has the angular velocity of v dot and angular velocity of double dot. Determine radial and transverse component of velocity and acceleration of the passengers. Meaning, you see this question do not give you any value, right? You just put your answer in equation. Meaning, if you follow these steps, you just give me the final equation. That's it. You get the full marks already. This kind of question come out last semester, final exam. Last semester, half of the class gone. They don't know how to solve this one using general equation. Because maybe because you are so used to given value kind of question. Okay. So start to think something in this direction. Sometimes you don't need to substitute answer, substitute value one. You only need to follow the SOP. First you write what, second you write what, completing the equation, then that's it. Okay, you need to find radial and transverse Radius and transverse component means r and theta. You observe, huh? So I give you the direction. You see what is the steps, huh? So you draw the object, you put in the center of the object, put in the axis r and theta. Don't confuse with the tangent and normal, huh? This is polar coordinate question. So r this direction, theta this direction. If you overlap the question with the tangent and normal, can, but draw tangent and normal direction here. N and T. You can overlap, but don't use the two set go along together. Don't confuse yourself. Okay, the next, this is just show you lah, the N and T overlap, what happened. Okay. So R is constant. Again, you need to find the R dot, R double dot, and so on. Then put in the R and R, a negative R. So in this case, your theta is moving this way. Why negative? Why negative? Because where is your R axis positive direction here? So the direction is pointing this way because the chair do not swing away. It remain in its position in the circular motion. Okay, so A is pointing inside. Negative is because the R axis is positive going outside. It's a vector. It's a vector, right? So again, write the equation. V something, A something. Okay. Substitute accordingly. You know that R doesn't change. R dot 0, R double dot 0, cancel here, cancel here, cancel here. At the end, you arrive at one simple equation. This is what expected lah. Huh? Because the question in the circular motion, this circle doesn't change R. This chair doesn't move away. What mean by R dot? R dot means the rate of change of R of this object. The R dt doesn't change. You get 0. R double dot means you differentiate 0, you still get 0. Yeah. Rate of change of this chair in R direction. Okay. So if you understand this one, you can do question with the value. You just substitute value or equation, you differentiate, you substitute inside. Then you get the final answer. Okay. Okay. So important is you understand the where is positive, where is negative. So okay. We have a break here. U theta is this direction. This one. This one. Theta dot 0. Not theta 0. Wait. Okay. This is magnitude. Magnitude direction. Vector. Vector have a magnitude and direction. You don't need to tell me what is this direction, because this velocity is in. If you write r dot theta, also correct lah. It just become a vector only. There's a difference between v equal to r and r dot and v equal to r theta dot u theta. This is scalar magnitude of the vector. Vector have direction, magnitude and direction. If you write this one, it become a vector already, because this one got magnitude and direction. It's just a presentation of answer. Okay, 10 minutes breaks. We continue 9, 10. Sorry, 3:10. 3:10. Okay, digest a bit the information. If you have questions, ask Milan.